Hey, welcome back to Mr. P. House with Algebra. This is Unit 3, Topic 1, Lesson number 2. So we're going to be talking about box plots and histograms and bar graphs. Those three different types of data displays. And we're talking about how they are best used for different shapes, different centers, and different spreads. Which will talk about how far apart the data is. That's your spread, and where the center is was your center, and your shape would be like if it's skewed more to the left or more to the right. Starts off with a pretty good warm-up. In this warm-up, it asks you to find the mean, median, mode, which are the three measures of central tendency. When you solve the mean, that means you add up all the numbers and divide by how many there are. You end up getting an answer of 81. And when you're finding the median, you put the numbers in order from least to greatest, cross them off until you find the one that's in the middle. And that's median would end up being 86. And the mode just means the one that is repeating the most, which happens to be 60. Now, the point of this warm-up, why I think it's such a great warm-up, is because it gets you to understand that mean, median, mode can sometimes be better depending upon what the data looks like. In this case, clearly, the mode is a terrible answer. That is not a good way of finding the best measure of central tendency. All right, so clearly you can tell in this set of data that the mode was no good because that's the lowest number. That's not a fair grade to give Sam, because if you give him a 60, I mean, you got all these other scores that are above 60, and that's not fair. But if you look at the mean and the median, you're going to notice that they're pretty close. And the reason why the mean is lower than the median is because there are outliers. These 60s are pretty low. They do not really belong. The A's and B's are all very close together, but the D's cause this mean to be lower than it probably should be. So in this case, I would say that the median is the best answer. And the reason why is because whenever there's outliers, you always want to use the median. Now, median is not always the best choice, because if I made a set of data where there was a couple of hundreds, and then, okay, that's 1,000. So a couple of hundreds for your grade, but then you also got 3 E's. In this case, the median would be 50, but that's not a good answer, because if you got 200s, why are you getting a 50 as your average? So the median in this example would not be any good. You would want to definitely use mean in that example. So mean, median, mode, depending on whatever the data set gives you, will determine which measure of central tendency is the best. So what do you notice? What do you wonder about this? This is called a histogram. This is probably something that you have never seen before. This is not a bar graph, even though it looks like a bar graph. Now, what's the difference between a histogram and a bar graph is it has intervals. This bar right here doesn't stand for all the people that chose 1, 2, or 3. It stands for all the people that chose from anywhere from 0 to 25. So that's the only difference between a histogram and a bar graph. A bar graph just has like one category for each item that could be picked, whereas a histogram could be all the people that chose in that interval or in that range. So all the people that chose from 25 to 50, or the number of texts, that's how many they said they send, are in this bar right here. What you should notice also is that there's an outlier. This person obviously spends way too much time texting. They spend somewhere between 350 and 375 per day. That is pretty ridiculous. Do your homework. Student peer coaching groups. So this is the way this part is going to, there's part 1 and part 2. So the first one we're going to start off with is making a box plot. And the way you make a box plot is you find the median of the data. So cross off lowest, highest, lowest, highest. Yes, I know there is a lot of pieces of data, so I'm going to have to cross off a lot of numbers here. Lowest, highest, and just keep doing this until you find the one number that's in the middle. Now, once you find that one number in the middle, that's your median. And what you're going to do after that is you're going to then find your 2 quartiles. So basically what you're doing in a box plot is you're splitting the data up into 4 equal categories. Lowest, highest, lowest, highest, lowest, highest, still going. Once you've got your 4 equal categories, that's really what a box plot does. It only separates things in 4 categories. If you looked at that histogram I showed you on the last page, you will have noticed that that last page, it showed you like 11 different categories. And I hope that didn't just mess up. So 1, 2, 3, 4, 5, 6, 7. I'm just going to assume that it was right. So 70 and 80, notice that they're both in the middle. So in between them would be 75. So it looks like the median is 75, because that's in between 70 and 80. Or you can add the 2 up and get 150 and divide by 2, which is 75. Now, what you want to do to find quartiles is then start crossing off the other direction, lowest, highest, but I'm going to focus on just the bottom half of the data. Lowest, highest, lowest, highest, lowest, highest, lowest, highest, lowest, highest. Like I said, there's a lot of pieces of data here. Lowest, highest, lowest, highest, lowest, highest, lowest, highest. So it looks like we got two numbers in the middle, and they both happen to be 6, so that's easy. The lower quartile is 6. Now I'm going to show you another way of doing this, which is count how many numbers there are and then find what number would have to be in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we know the 12th and the 13th number are in the middle. So I'm going to do that the same here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it looks like 150 is going to be in the middle here. So 150 is the upper quartile, or the third quartile. And the median is technically known as the second quartile. This is the first quartile. All right, then the last thing we need to know is we need to know the extremes, 0 and 370. So I'm going to go down here. I'm going to make my box plot. I'm going to start at 0. Now, if I went by 1s, I would never get to 370. So I'm going to go by 20s. 20, 40, 60, 80, 100. 120, 140, 160, 180, 200. 240, 260, 280, 220, 240, 260, 280, 300. And then 320, 340, 360, 380, 400. So now I should be able to fit all the pieces of data. 0 was the lower extreme. 370 is the upper extreme. 150 was the upper quartile. That would be about right there. The median was 75, 20, 40, 60, so somewhere between 60 and 80, but closer to 80. And what piece of my data am I missing here? The lower quartile was 6. So if this is 20, that means 6 is all the way down here. Now, what you're noticing is a box plot, it's really skewed to the right because most of the data is on the left-hand side. Skew just means where most of the data is. If it's pushed to the left or pushed to the right, and you notice that we have a very big long whisker on the right-hand side. So this is a skewed right. And the median is right here. Now, if I was using this to find the mean, it's not very helpful. But what I do also know is that a lot of the numbers in this little piece right here, if you think there's less numbers in that piece, that's not correct. It splits up into 4 equal parts. There are just as many numbers in this big long whisker as there are in this small whisker. The difference is that these numbers were much closer together. So, box plots show you how far things are apart. It does not tell you how many numbers it represents because they all represent the same amount of numbers. All right, so talking about that, what does it mean in the data? I already mentioned that because it's not possible to find that on a box plot. Which data display best represents this mean, mean, or mode? I would say median is the best because, you know, it's right there. That's what a box plot does. Or I could say that there are some outliers out here. So that's the reason why median is the best choice because there are outliers. Remember from the warm-up, if there's outliers, that could cause the mean to be too high or too low. The histogram box plot better represents. Okay, so comparing the box plot. So notice that this splits the data up into 4 parts, whereas the box plot can split it up. I'm sorry, I call this box plot. It's a histogram. The histogram splits up their data into way more parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. So histogram is better at showing spread because it's splitting up the data into more groups. But if I'm trying to find the center, this is not very helpful. I cannot find where exactly is the middle, but on a box plot, the middle is easy. It's right here. It's right where the median is. So those are some differences between the histograms. Those are the pros and cons there, and box plots. All right, so this is a box plot. And what you might notice is that there are these little X's. You might wonder, what are these little X's? Those are outliers. So typically, you do not connect an outlier to a box plot. You leave it separate. It doesn't have to be X's. You can use circles, but the box plot should be connected to either the furthest, either the highest or the lowest number that is not an outlier. So those are your extremes. Rachel wants to continue to send her normal amount, and her mom would like her to decrease this by half. Present an argument for each side using mathematics to justify each person's request. Be prepared to present this to class. Now, if you look back at Rachel's data, because I believe Rachel's data was the box plot, you'll notice that people are sending lots of texts. Probably because, you know, she's a teenager. Teenagers send a lot more texts. And then her mom collected data, which was here. And her mom collected data, which was much less. Oh, I forgot where it was. Must have been on a different chart. Okay, but this is the same data right here. This is just the box plot of Rachel's data, which is average of 100 per day. And our mom would like, so the median is at 50% of the data. So 50% of the data is at the median. Notice that this one, it takes away the outliers. So in this case, the median is right here, which makes it, half the people send more than 150 texts per day. Whereas her mom would say, these outliers down here, this probably means that you got to count those. So those are less, they're using less than 150 texts per day, and you got to take those into account as well. What are the advantages of looking at data in different representations? Well, different representations, like using a box plot versus a bar graph versus a histogram, they show you different pieces of data. They show you, it spreads the data out differently. It shows you different spreads. Hopefully the skew should be the same in all of them, no matter which one you use. And they also show you different centers, whereas a box plot only shows you the median, where you might want to use something else. You might want to use a bar graph if you want to try to find the mean, because then you can add up all the bars and divide by how many bars there are. So getting back to some of the vocabulary that I've been using, this is also probably posted on your Google Classroom. We've got shape, center, and spread. Shape is the skew. So remember what I talked about before. Skewed left means most of the data is on the right. Yes, I know that's backwards to what you would normally think, but that's the way it is. Skewed right is when most of the data is on the left. And we call this a bell curve or a normal distribution, when all the data is in the middle and it kind of curves out like such. All right, so that's spread. So we also have, no, this is spread. So here we go. So variability. Variability means how spread apart the data is, whereas the shape is the skewness. So how far apart, you want to think about things like range or interquartile range or outliers. Those are the three things you want to look at when you're looking at variability, or how spread apart the data is. And you can just look at these graphs and see. Well, we'll talk about this one later. This is a scatter plot. We'll talk about trend lines later on coming up as well. And last but not least, we have center. And that's easy because you're trying to find the center. The mean, the median, the mode. Those are three ways of finding the center of the data. All right, I'm actually going to stop right here and leave this part 2 for another time. Basically what we're doing here is comparing these sets of data, noticing like how they look different and what makes them different. Notice that this one is a histogram, this is a box plot, this is a histogram, and this one is it's kind of like a bar graph, okay? Thanks again for watching. Please give it a like if it helped you learn anything about box plots, histograms, or bar graphs, and subscribe if you haven't done so already. Thanks again for watching. Have a great day.